This conference will now be recorded.
This is day 3 and I welcome you all to this day 3 session. Today we are going to discuss data structure algorithms. There are different data structure algorithms like important algorithms are stack, another is the queue, one more is called tree, then is one more is a set like this, a map is also there, and some sorting related algorithms and searching related algorithms. So basically implementation is a one part in coding, and application use is another part. So we will discuss three main concepts about these different data structures. So we will discuss first what is stack. So stack maintain the data in a particular let's say uh, top of other different objects. If you place a one object, if you take one more object, so you can place that all objects on top of all the objects. Let's say here I want to create data collection of employee records. So there are different employee records. So I create structure employee, and there are different employees. So I need employee code, character, employee name, then is employee salary. So in double type we take salary variable like this. Here is the double type allowance variable, and double type gross income is a variable, gross income. Okay, so there are some variables. Now we need different objects of structure employee. So I type structure employee e1, e2, e3, e4 and e5. They are different objects. Now how to store these objects? We have different options. The very simple option, you can create array. Okay, you can create array to store the data. So let's say I created array of 5 elements, and there I arrange all the employee data e1, e2, e3, e4 and e5, different objects. Okay, we hold that data here. Array you can access using index numbers. Index number begins with 0, ends at total size -1, and these are the all elements I'm going to access using the index numbers. Okay, so very simple thing, you can create array and store the data. Another way to handle the record is you create list. You create list. Now list is a algorithm in data structure. Okay, list is a algorithm in data structure. So first we will discuss about the list, then I will tell you about the stack. So list may be linked list, list may be doubly linked list, or circular linked list. They are different algorithms. But what is list? So list store linked records. List store linked record. Okay, now I show you how. So this is the first one, memory address, and there I hold object e1. Okay, there I hold record of employee e1. Here is a first record. Here is a first record, maybe like employee code, employee name, salary, everything. This is the first record, and who is handling this record? E1 is responsible to store this record. Similarly, you here store a one more record and link it to the 2423 memory address. Here you create a variable called next variable. So this is a pointer variable. Pointer variable next, and this variable hold the reference of its next record, hold the reference of its next variable. Now such how many nodes I can create? Many different nodes you are going to create, and you are going to hold such many different objects. Let's say this is second one. and this is third one, and so on. You can create such many records. Okay, so this is another one memory address, and here you store one more employee record, E3, E2, E3, all that different employees. Here is E2 and here is E3. Okay, so they are all the employees. So you first understand the only concept of what is list, what is stack, what is queue, what is map, what is set, all that concepts you understand. And don't worry, if you don't know about the implementation part of these all algorithms, I'm going to share you some of important notes about the data structure. So following that concepts, you can understand the implementation logic of that all algorithms. So for the first 15 minutes of this session, understand only concepts. So I'm telling you about the list. Already I discussed about array. Array store records in at unique index, right? This stores records using linked records like this. You just uh, keep going on, create the links and create the records. So this is the another option. You can create records. Now third one option is you can store these records one more way. It is by using stack. So what is stack? Okay, I here tell the stack is nothing but store records one on other. So first you create something like this structure. The first employee record you hold here. Okay, so you are going to hold how many employees? One, then is second, then is third, then is fourth, and then is fifth one record. Total they are 5 employees, right? They are total 5 employees, and such many employees actually you can create as required. Right now we will hold only the 5 employees. So here I write the employee 1, on that you hold second employee, on that you hold third employee, on that you hold fourth employee, and on that you hold fifth employee. But the rule for stack is you can only manipulate the top record. Who is the top record? So top is the one variable. So when you start stack, top by defaultly points the -1 record or null record. Top is pointing by default, top is pointing by defaultly the -1 record. Okay, -1 record. So let's say here is the top. If you create top as integer variable, then it points -1, or it points, if it is a pointer, it points null value. Okay, so when you add the records, top points to the top record. So in my case, who is top? E5 is a top. So what is the rule of stack? You only can manipulate the top record. It is a rule of stack. So here in my case, the E5 is a top record, and if I ask you question, change the employee code of employee 3, then you first need to remove the A5 E4, then only you can change anything of third record. Okay, so this is the concept of stack. Another one way to store the record is using queue. Store records, one after other. So you can create a queue. Okay, option number 4, you can create a queue. Option number 4, create queue. Now how to arrange these records using queue? So you know already what is queue, because while reserving movie tickets or in college for admission, you stand in a queue and waiting for the ticket, right? So this way also you can manage the records. So here is the first one record, second one record, and all the records they wait until the next one completes the job. So this is in a queue, this is in a queue. Like this, many records may be in a queue. Okay, many records you keep in a queue. So let's do this third, fourth and fifth one. So here are the records. So in queue, the first record in my case is E1. Okay, like this you can create student object, you can create player object, any data, E4 and E5. Until E1 completes the job, E2 cannot enter the counter. So this part is called as front and this part is called as rear. So they are two different variables to manage queue. So there are many ways you can use to store the records, but as a C program means, you if you only knows the C programming, then only you worked in this first one category, option 1, creating array and hold the records. But there are so many views, so many options you can use to store the records. Like this, tree is there, set is there, map is there, sorting is there, right? So what is tree? Tree means create hierarchy, create hierarchy, and and using traversal techniques, using traversal techniques, read records. So there are many different traversal techniques. One is pre-order, second one is post order, and one more is the in order. There are orders. Using that you can read the tree. So option 4 is the queue and option 5 is create tree. So how to create tree? So based on employee code, I'm going to create tree. So consider the different employees and the code you are typing something. The first code is 89, second code is 63, third code is 19, fourth code is 42, and fifth code is, let's say, 100. So there are some employee codes. Okay, sample employee codes. I given some sample employee codes. Now reading these codes, you can store the records in a tree. How to create tree? So to create tree, you first create a root. So this part is a root. Here I'm created a root, and you start with this first one key called 89. I store here 89. After that, go for the next employee code. The next employee code is 63. Rule of tree is the value of the selected user input, if greater than root element, then add it to right side, otherwise add it to left side. I keep a comment here for you, that is value selected if greater than root element, then add to right side, add to right tree, otherwise add to left tree, otherwise add it to left tree. So this is the root, right? Here I write a very short comment notification, that is it is a root. Now we will create a one more record. Now second record is 63. 63 is greater than 89 or less than 89? Less than 89. So go for the left side. Go for the left side here and add value called 63. Here you type 63. Okay. So 63 is called child because we are adding after 89. So 63 is child for 89. 63 is child for 89. Okay. Now what is next? Next value is 19. So 19 is greater than 89, false. Go for the left side, but already there you created value 63. Don't worry, compare 19 with 63. So 19 is greater than 63? No. So you create a one more here record as 19. Store here the value and here is a 19 like this. After that go for 42. So 42 is greater than 89? No. 42 is greater than 63? No. So 42 is greater than 19? Yes. So here you create, now it's right side because 42 is greater than 19. So here you create record like this. Now what is next? The next is 100. So 100 is greater than 89 or not? Yes. So go for the right side. So here you create 100. So this is how you can store the records. This is how you store the records. Now let me give the employee object names, references. 89 is the first employee. So here I write, for your just understanding, here I write this is E1, 63 is E2, 19 is E3, 42 is E4, and 100 is E5. Correct? How to print this record? Using some traversal techniques. There are some traversal techniques. Traversal techniques in apti interviews or the tests. They ask you about to use the pre-order technique to print the record, in order technique to print the record, post order technique to print the record. So if you know the algorithm, then only you can write the orders. Okay. So what is pre-order? Pre-order means it always starts with the root. So this is the pre-order. What is in order? In order means in middle always root comes. And what is post order? The post order means root comes last. So here the pre-order of this tree will become 89, then is the 63, then is the 19, then is the 42, and then is the 100. So this is called as the pre-order. What is in order? In order means root comes in the middle. So it like 42, 19, then is the 63, then is the 100, and 89. Here it comes 89. Okay, like this. And what is post order? Post order means root comes last. Post order means roots come last. 42, then it comes 19, then it comes 63, then it comes 100, then it comes 89. So you are going to work with tree. Once you understand how it what is the implementation logic of tree, I will send you some notes. So preparing that, you also able to can write the exact correct orders of the values. So I told total different 5 techniques how you can store the records. There are more techniques. Now set and map is nothing but create unique create unique collection. Okay, duplications not allowed. It is called as a set. Duplications not allowed. It is called as a set. What is map? Map is the key value pairs. key value pair records called as a map. What is sorting? There are different algorithms: selection sort, bubble sort, quick sort, as well as insertion sort and merge sort. So in the programming rounds, they may ask you about using insertion sort, solve the following question. Using selection sort, solve the following question. So there are some data structure algorithms, and searching already yesterday we covered. There is linear search and binary search. They are two different techniques to perform searching. Now, what kind of questions they ask you? So here we will discuss questions. So here is the question one for you. Question one is create singly linked list. Create singly linked list to store player records. Player records. Check that player records. Ask user. Ask user uh, player code and write algorithm to add new player after given player code. So the question I explain you using the diagram. Let me save this diagram for you. Later I share you this on email. Okay, so this is also important. So I save this inside this folder workshop, and later once I complete I share you. So this is day 3, and here I save this as diagram explanation. Correct. So let's go for one more new drawing, and here we will discuss the question. So consider you are created some records of player. So for player, what we want is, I want player code, I want who is player, and then I here going to store the next place. Okay, the next place. So these are some required attributes. So what is the first attribute? Player code. Next attribute is player name, and next attribute is the next player. Always this variable is a pointer variable, points to the next record. So this is the memory address of first player. So who points this record? Player 1. Consider player 1 is pointing this record now. So how many players you want? Such total 3 players asked to create. Such total 3 players. Okay, memory address of course different. 7823 is the memory address, and here is like 4772 is the memory address. So they are different players. Now that records you are going to link with each others like this. Correct. After that, the question is, once you create the linked list, to ask user to enter a player code and write algorithm to add new player after the given player code. So let's say here you created these records, and player code user inputs something called 892 is the player code, or 112 is the player code. So this player code you compare with all the existing records, So is this matching with player code first, player code second, player code third? So if it is matching, then what you have to do is, after that particular player, create a one more record of the player. Correct. So for that, what we will do is, here first I write this hash include stdio.h code, then is the main function. And also remember, these type of questions are asked in the Aptitude or programming rounds. You solve only in 30 or 45 minutes. Okay, so you must type fast and correct. So here is I create a structure as player, and see in very less time I can complete this code. Now here I type integer player code is a one variable, player name is a one another variable. After that, here is integer, no, that is player next record. Why to create this next? Because I want to hold the next player record, right? So here is a n. So sample input is given. Sample input is given to you, that I type that sample input. Let me go for the next line. So here is the sample input. First is you enter value as 5. So what is 5? 5 means how many players. Secondly, you start entering the records of player. 101, who is player? Let's say Virat is a player. 102, 101 is Virat. 102 is, let's say, Sehwag. 103 is Sachin. 104 is Hardik, and 105 is, let's say, Dhoni. So they are all the records. After that, you ask user another one input, that is enter the player code. So user enters the player code 103. So after that, you enter after the 5 values, after the 5 different inputs. Okay, once you complete these inputs, so user is entering 103. So 103 exists or not? Yes. So then ask user to enter the new player code 106, and after that, here user enters the name of that player. So name of that player is Yuvraj. So now the output will be, sample output will be like this. You print 101, here print the name of player, 102 name of player, 103 name of player, and you added a one more player Yuvraj after 103. So here it is Yuvraj. After that, 104 comes is Hardik. Then is comes 105 is Dhoni, and that's it. So this is the sample output. So this question is completed here. But if player not exist, if player not exist, if user input player code not exist, then print error player code not found. Okay, so this is the question, but I keep this as for notes, as for your reference as it is. And let's save this question as day 3 question 1. This is question 1.c. Okay, so I ask user about the n. N is the how many records you want to create, correct? And after that, here I'm typing the object of structure player. So here I type definition, type definition, and I type here player. And after that, here we write player star some variables, current first, then is the one more pointer, and by default we keep first and that follow pointer as null. And here we are typing scanf %d address of n, how many players. Here I keep a comment, how many player records. Here user enters the value of n, and then starts a loop. Let's say a loop starts with s is equal to 1, s less than or equal to n, s plus plus. Okay, so that many times we will ask user to enter the data. So I am typing, first is the memory. You here reserve the memory space. Now step starts, reserve the memory space. Step 1 is reserve memory space. Okay, how to reserve memory space? Here you write player memory allocation and then size of. Now you type player like this. Nextly you type current. If the first comes null, then I'm typing the first and the follow pointer comes to the current location, and after that I type if it is not, then the follow pointer next address becomes current, and follow pointer goes to the current location. So this logic, don't worry, I'll explain, and using diagram we will see the line number 60 up to 68 how it works. And after that I'm typing here scanf %d address of current player code current player code. After that I type scanf %s address of current player name like this. Okay, so once I complete this I type current next becomes null Okay, now how it works. So this is the code, starts with s1 and ends at n. How many players you want? Let's say in my case I want to add total 5 players. Okay, so the first case is allocate the memory space. So here is the first one memory space. I created. After that, ask user check first is null or not. So I allocate the memory using the current memory address. So here is the current as a one variable, store the reference of first player, stores the record of first player. Okay, and then you're typing the first is null. Yes, first is null. Then what? Store the memory address of current in the first and follow pointer. So the two more variables called first and one more variable called follow pointer store the reference of that same location. So where is current? 8924. So the two more variables comes to the same place. After that the else will be ignored because first is null. Scanf enter the player code, enter the player name. So I enter the player code here as 101, enter the player name here. Who is the player? So first player I want to enter as a Virat. So Virat is a player. So who is the next record? In my case the next record is null. Right now it is null. Okay, it's null. After that the loop continues, reserve the one more memory space. So here another player record created, one more. Okay, new player record. So here also it reserve the memory space for player code, for player name, and to store the next memory address it holds the memory address here. Okay, so let me type the attributes, player code, player name, and last one is the next memory address. Okay, so I keep this one as a copy here somewhere, and then I type here the memory address as 8642 something else. So current current is now leaving this memory address and goes to the next address. Okay, current leave the memory address and goes for the next one. After that what? Now the first is null. No, first is not null because there is the address 8924. So that's why else part get execute. Who is follow pointer? 8924 is the follow pointer. So the next of that follow pointer you store the reference of current. So now the null get override the null get override, and here it stores the reference of its next variable. So it links that value. Okay, it links that value to this current address. It links the value to the current address like this. This is how the linking done. After that, what? The follow pointer goes to the current memory address. So follow pointer also leave the memory space and goes to the next address. This follow pointer leave the memory space and goes to the next address where is current. Okay, like this. So let me know your feedback. I'm going correct, and the technique I'm using to explain you the data structure is convenient to you. So you can use this chat box to drop your message. So let's go ahead. Now here, next player record I enter as 102. Who is player? Player is Sehwag. And then here is the code. The follow pointer now store the next address. I entered the data. Current and next becomes null. Here by defaultly it stores the value null like this. And after that, the loop begins again. Current moves to the next record. One more new record of player here. Okay. Now the memory address is here as something else, 7645. Current moves to the next record. Current is leaving the existing space, goes to the next. Now here the null will be override with the next address using this follow pointer, and it links the memory address. Similarly, pointer also leave the memory space and goes for the next record. So this is going to happen for total 5 times. Here is the 103 third player, and I store here the player name as, who is third player? Sachin. So Sachin is a third player. So after that, the next becomes by defaultly null. Next becomes by defaultly null, and one more address get created. One more new address here. Okay. So these are 3 records only, but one more new address here get created, and here is a one more copy. So what is the next address? Here is the next address. We type 4531. So current lose the existing space and goes for the next record. Okay. So I'm doing this in front of you for first time. That's why I'm creating these records slowly. Okay. So you also can understand how the data structure algorithms work. Later on, from the question number 2, we will jump on directly the question part. We will focus on only the logic. This is the implementation. Okay. So first you understand how to create the records, in behind how it works, so that it will be easy for me also and you also to understand the logics. Now here I created the next one record. I enter the data 104, 104, and then is here the player name. Who is player name? Hardik. And the next record becomes null, because you're typing the code here as store the null. Once you enter the data, store the null. So that's why this becomes null. Okay, this becomes null like this. But what happens is, the previous one, this pointer object is now going to erase this null value and hold their memory address of its next record. So who is next? 4531 is the next. So it links that memory address always, and follow pointer goes for the next address like this. Now one more record I'm going to create. So that one more record is 105. Okay, one more record is the 105 here. And now current leave the memory address like previous records. Okay, current leave the memory address, and then here is the memory address. So the memory address I type 3765. This is the address. And after that, here the follow pointer will link the new address, and it also leave the place 4531 and jumps to the 3765. So this is going to the next point here, and here is my last record 105. Then is player name, who is the last player, Dhoni is the last player, and then is the next becomes again null. Next becomes null. I hope you understood this logic. Okay, how the records get created. The next is, now ask user after which player you want to store a new player. So here I ask. After this, I type scanf %d and I type user player code. So user enters a player code. So declare one variable here also, integer user player code, and here is a yes variable. Let's save this question first. Always remember to save. And then after asking, I'm going to check the player code exists or not. So how to check? So I take a one loop. I type one means true. Here is a one temporary object where I hold the first memory address. Okay, and then I'm typing if the temporary pointer pointing player code is it matching to user provided player code or not. So if it is matching, then what? If it is matching, then I hold that reference. How I hold that reference? I just type uh, found pointer is equal to temporary. Found pointer is equal to temporary. Okay, and then I also type break. Found pointer is equal to temporary, where found pointer by defaultly is null. Found pointer is by defaultly null. So declare two more pointers here. One is the temporary and one is the found pointer. Found pointer like this. Okay. So what is next? Once I done this, I here check the temp pointing next record. If it comes null, if it comes null, then only break this while loop. Otherwise, the temp will always go ahead. Temp will always go ahead. So check this. Temp is pointing the first record. So now temp is here. I type this temp. This is the temp star temporary object. Now temp is pointing the records. So here temp is pointing this record, first one. So check this. Is it matching the user given player code? So user is entering what? 103. User is searching for 103. So is the temp pointer player code matching 103? No. Go ahead. 102 is matching? No. Go ahead. 103 is matching. Okay. So the found pointer, I store found pointer. Here is a found pointer. Check this. I assign the temporary object. So here is the one another object I reference, and that is found pointer. So this is holding the reference of this. After that, what I will do? After that, the temp is break. I break this loop and I write here one more line, that is the found pointers next is equal to found pointer next, like this. This is a one more variable here. Okay, So this is another pointer variable now. And what I will do after completing this loop, if the found pointer comes null, then I print the error message as printf. What is the error message? Here is given the error message, player code not found. I write this message, player code not found. And else the data if found, then ask user to enter the new player code. So again write %d comma. So here you are going to create a new reference for current. So I type a code here as current goes for new memory address. So I'm typing this is player star, this is player star, and I type memory allocation for size of player, memory allocation for size of player. After that, what you do is ask user about the details, %d address of current player code, scanf %s address of current player name, and then is here you write a code found pointer next you store currents next becomes found pointers found pointers next, and then current also jumps to follow pointer at the last. Okay, and then your code done. Now you write one more loop, this one same loop to print the records. Okay, so here you will print the record. Now this is not necessary, this also I remove, and just type printf /n %10d %20s comma temp player code temp player name. Okay, so this is the code. They are total completely 125 lines, but if you understood, then you can handle any of questions in apti test or programming rounds. I tried my best to explain you what is data structure algorithm and how it works. Okay, so let's execute and see the output. Is it matching the requirements or not? So I hope everything is correct, but still we will check out all the lines. So here we should write like this struct. And what happens when we try this code on online compilers? So they run the test cases. So all test cases must go true. They are total 10 test cases. Okay, so remember that. std_leave.h. Now compile. Now let's execute. So some inputs. Oh sorry, the first input should be what? How many players? 5 players. 101 is Virat, 102 is I think Sehwag, 103 is Sachin, 104 is, who is 104? I not remember, I think Hardik, and 105 is Dhoni. Now here you enter who is the player, after which record you want to add a player record. So after 103 I want to add 106 Yuvraj, like this, and done. Perfect, I'm getting my output. So this is how you run the codes. This is the data structure algorithm, list algorithm, and the questions asked you in this type of manner. Okay, so what if the data not exist? Let's try something else. I want to add 3 players, 101 Virat, 102 Sachin, and 103 Dhoni. So now I enter another one, 105, means I'm searching 105 is exist. So it is saying player code not found. So everything is correct. So this is how you try the logics and prepare yourself to work with any type of questions. So I have some plan that I'll share you through email tomorrow, because tomorrow is the last session, and going through that you also can write this type of programs and sort out the problems. I hope you understood this logic. Okay, so I'm moving on another question, similar question. Here is a question number 2 now. Question number 2 title is prepare array of structure structure student to store five records as given below. Question 1 they are asking for convert array records to doubly linked list and show using function. Question number 2 they are asking. Question number 2 they are asking from student records. Create array of their scored points and show using function. So there are two different questions. So they given some records here, actually some student records. So they given some records as the roll number, then name and some points. So the roll number is 83, name is Smith, points scored 77. After that, roll number is 86, name is John, and the points are 16. Then is 73, name is Matthew, points scored are 19. Roll number is 37, name is Elise, and then points scored are 30. And one more student, 38, with name Peter, and the points scored are 82. So they are the records. So you given these two questions. So let's start this code. Hash include. Now I think 10 minutes are enough to complete this code. If I just type without explanation, if I type this code, the only 10 minutes is enough. But this is possible if you are very good in logic. Okay, so I'm creating here a structure called student. Let's create the variables. Roll number, character, student name is another variable, and scored points is a one third variable. I type the definition here, and then I'm typing student like this, and after that here we create the records. So student is equal to, in curly brackets, we create the records. So I'm typing the first record as they given the records already. So 83 is the first record, name is Smith, points scored 77. Second record is 86, then the name is John, and the points scored are 16. Third record is 73, name is Matthew, and then points scored are 19. Fourth record is 37, name is Elise, and points scored are 30. Next record is 38, name is Peter, and point scores are 82, like this. So this is the structure is ready. Now how to convert this to doubly linked list? So to convert this to doubly linked list, you first create some variables. Okay, so now this case I'm creating the global declarations because I'm now going to work with functions. So here the global declarations are, I'm typing student star first, then I type star first is equal to null by default. Then I'm typing student star follow pointer is equal to, this is by default null. After that, student star the next and previous two records you will hold. We also create the temporary variable, right? So here I create the two more variables. One is called structure student next record, and structure student previous record, like this, previous. Okay, struct. Done. Now what is next? Now convert these records to uh, the doubly linked list. But they are asking about function, using function. So now how to convert this using function? Call here convert records to doubly linked list. This is my function name, very long name. Student stud records is equal to, like this. So this stud records you pass to this function. Now what is next? You define this function here, void convert to list. You are going to take that details records, like this. Now you write a loop. I stands for 0, I less than 5, I plus plus. Now you reserve the memory space for that records. So I create student type of, here you create a one more variable called current. Okay, I forgot to create, so I type current, and then I here type current address becomes student star, and I type memory allocation size of student, like this, size of student. And then what I type here, if the first is null, then the first and follow pointer points to current address. Otherwise I type the follow pointer hold the follow pointers. I type follow pointers student roll number. No, follow pointers next will be current, as well follow pointers previous will be uh, here is the one thing missing. Follow pointers next is equal to follow pointers previous is equal to null, and here is the next will be current, and the follow pointers previous will be the uh, current previous. Follow pointers previous will be the current previous. Okay, the doubly linked list meaning is you're holding the next and previous both records. Okay, so if the follow pointer is pointing the second one, then you also want the previous record. So let's talk about this previous letter, but I'm holding at least the next record now. But after this else part, what you write is current roll number is become records of I dot roll number. Okay, current student name, you copy this using string copy function in the current student name from records of I dot student name, like this. Student name is variable here also, and one more variable we want to store points. So in the structure you create points variable, and you hold the points from these records. So you access points. Current points is equal to records of I. So records of I is a structure object. We access the points, like this. Okay, done. I save this question number 2.c, and I created the 5 records. Okay, so first the current is created, and when the current is created, every time you create the current object, it should be inside the loop. So the first is by default null. Then in that case, the first follow pointer are become current, and its previous variable and next variable also null. But for when you go for the next record, you type the follow pointers next will be current. Okay, follow pointers next will be current. Then you write follow pointer is equal to current, and then you type follow pointers previous will be follow pointers previous will be current previous. This is correct. Current previous. Okay. So when you create these records, you're holding these values. Okay. So the follow pointer is pointing to the first record by defaultly. So there you store the next as a current, correct? And then follow pointers to this one. Here is going something wrong. The last one. Let me go for this diagram. So these are three records. So here is the follow pointer, and same here is the current pointer, right? So there are some memory address. First one address, second one address, and third one address. So here you hold record of student, and you created some more variables. Star previous is a one variable, star next is a one variable, right? So these are some variables, all the records here. Okay. So when you create the first record, the next will become the by default follow pointer is on here this side. This is pointing to this address. So I should write follow pointers next should be current. That is okay. Current previous should be follow pointer. Okay, okay, okay. Current previous, current previous should be the follow pointer. Now it is correct. Perfect. And then follow pointer should go to current address. Follow pointer leave the place and go to the next address. That is correct. Okay. So done. Code is done. So you store the records and finally you write current's next address becomes by default null. Saved. 5 records are converted. Now you write temporary is equal to first. Then you write while loop 1. Then you write printf percent 10d percent 20s percent 10d comma temporary points to roll number, temporary points to student name, temporary points to points. Okay. What is next? Next is you write if the temporary object points temporary object next address is if equal to null, then only break the loop. Then only break the loop. Otherwise what? Otherwise you write temporary is equal to temporary next, like this. So this code is completed. Now you declare this function here at the top of main function. Save this code. Let's compile. It is saying what? Incompatible type of argument 1. Convert records to doubly linked list. Struct a student but argument of type student. I think type definition is wrong. Student. I'm typing student. I'm passing the array record. Okay. Array is missing. Compile. I not declared. Integer I. Compile. Now malloc, and for that you need here the two more header files. One header file is hash include std lib.h, and another is hash include string.h. Hash include string.h. Compile, run. So /n is only missing. Everything is correct. We add here /n, and my question 1 is completed. So keep patience, because while you're learning these concepts, I know only in 1 hour as a beginner, it's really hard to understand the logic. But at least you go through the session just to understand what type of logic is expected and how to implement this, what kind of logic you must learn. So these are the answers from me to you, and learning that you can decide what to be the choice. Okay, so this is the question one completed. Question one was create and show using function. From student records, create array of their second scored points and using function show that. This is very easy. You just create a new array and store there the points. Okay, so here you write one another function, create points array, and you pass the student records like this. I write it here. Go next. This is student records. Void. Now how to separate it? I create one array of points, 5 elements. That's it. For I from 0, I less than 5, I plus plus, and I write only one code, that is points of I is equal to points of I is equal to records of I dot points, and then is you print the data like this. I just keep some slashes, and then I start one more loop. I from 0 to I less than 5, I plus plus. Go next, write printf, and here you write slash n %d comma points of I. This is only the code. I created here one variable I. Now declare this function at the top of main here. Check this, compile. Okay, so this should be after the variable name. Now here I write this once again. Brackets are wrong. Save this, compile, and run this code. So you are getting only the points array. So these are the two questions I discussed with you today, and these are very complex questions today. So first you need to learn at least of these algorithms, go through the very small examples, then you will be able to understand the logics. Okay, so this is what the data structure is. I still not covered anything of stack, queue, tree, set, map. To understand that also you need to spend more time, and today we are out of time, so we are going to stop this session. But I'm going to share you some documents, related notes. Go through it and understand the logics implementation code of these algorithms. Okay, still if you have any doubts, any queries regarding these topics, you can personally call me or WhatsApp me. We will discuss. So thanks for joining this session. Let me know the feedback, and we are going to end this session.